to do dilations, okay? So, yeah, what's a dilation? Well, yes, it's a change of size. And which way can it change?
An enlargement.
It can be an enlargement. We did this on day one. We talked about the names. An enlargement or?
Reduction.
It's a reduction.
I would have been shrinkment.
I know, enshrinkment would be way cooler, but alas. Okay? Now, the thing is when you grow or shrink something, it actually grows or shrinks around a fixed point. Artists use this point all the time. So if you have your original and your image and you connect those dots, however far you want to connect them, okay, eventually any dilation, all those lines will meet at one point. And they use this in art a lot to be the center of where you do your perspective. So if you want to like show going down a hall, or if you were to draw this class and wanted to make sure the lines on the ceiling were done right, it would all be around a point of dilation here. But alas, we don't get to call it a point of dilation because that would be too simple. So it gets a fancier name, just like it wasn't called a point of rotation. We don't get to call it a point of dilation. So what should we call it? Everybody's looking back into their last class notes to see what did we call it when it was a rotation? What's that point? Yeah?
Is it center of...
Center. The center of the dilation. Okay. And oh look, where does my center of dilation happen to be here? What's that? This one happens to be the origin. And things are nice and simple when it's the origin. So you want to just keep it at the origin for today?
Yes.
Sure.
Yee?
Yeah.
Oh, and look, the next class is the quiz, and then we're done with the unit. I guess you won't ever get to learn how to do it not around the origin. Darn. Actually, all it is a translation and then the dilation. And so you add and then enlarge. It's very hard. But you don't get to do it. You don't get to. If you want to have that secret hidden knowledge, you're going to have to look it up for yourselves. Okay? Now, a dilation does not preserve congruency. It preserves shape, but not congruency. Now, we had something to call things that did preserve shape and size. Yes? Well, similar is what the shapes are, but what is the kind of transformation that does not preserve congruency? To give you a hint, the one that did preserve congruency was a rigid motion. And so what would be one that does not preserve congruency?
A non-rigid.
A non-rigid motion.
Wow.
I know.
You math guys are creative.
I know, well, normally we come up with a fancy word. If it's not a rigid notation, let's come up with something really disgusting to call it. But alas, this time it's just not rigid.
An alpha-beta transformation.
Something like that. No, an aleph-bet.
Alpha-beta.
You want to use the right set of letters.
Yes.
Okay. And so we've got our non-rigid motion, meaning it doesn't stay the same size. The sides can expand. But notice something. All the corresponding angles are going to be congruent, and all the corresponding sides are going to be proportional. Wow, that sounds like something we already did. How are the shapes related when you do a dilation? I heard it, what? They're similar shapes. Or in this case, similar figures.
I want to hear figures that out.
Yeah. Okay. So wait a minute. When we did similar figures, how did we tell how much bigger or smaller was it? How did you tell how much bigger or smaller similar shapes were? The scale factor. Ooh, raise your hand, Candy, to whoever can tell me how you do a scale factor. That was pretty fast. Go ahead. Marcus?
Newest over oldest.
It's new over old. Remember doing that garbage?
Yeah.
You're going to have to remember how to do that today. Okay? And guess what letter we're going to give the scale factor? You just answered one. I need new blood. Yes.
K.
We're going to use K. We keep using H and K, so we might as well use K.
Okay.
Why not?
Okay.
Okay? Now, on day one, I told you how to tell if the shape is being enlarged or reduced. And it has to do with this scale factor. And we wrote it down even. How do I tell just from my scale factor if it's an enlargement?
If it's over 1.
If 1 is over 1.
The scale factor is over 1.
So if K is greater than 1, it'll be an enlargement. And so that's where your numerator is bigger than your denominator. So it might be a whole number like, say, 7, but it might be an improper fraction like 9/4. Oh, by the way, guess which thing is always on top again in your scale factor? The new. Look, the new is bigger than the old. That's how you can tell it's an enlargement as well. I know, it's mind-blowing. I can just see brains going everywhere. Okay, so for an even bigger challenge, Aleda, what's the other version? Okay, and so I'm going to just write it in the same order though, so I'm going to say when K is less than 1. So I just flipped what you said over.
And then the dilation is a reduction.
It'll be called a reduction. So if I have a fraction smaller than 1, now technically, this is stuff that's bigger than 0 though. Okay, we're not going to have dilations that are negative 63 or something like that. Okay, we're going to stick with positive values for that. And so what's something way a reduction could look? What? 1/3. See where the new is smaller than the old? Oh. Wow,
Epsilon.
you're impressed. It's amazing. Okay, so let's write the rule down. You know what? I want you guys to all work together. As a table, work together. I want you to write the rule. If you have any random point, and your scale factor is K, what do you think the rule for the mapping will be? What do you think it's going to go to? And you can come up with it on your own and get the candy, or you can ask other people and...
Oh, it's going to be KX.
Okay? I'm going to give every table a chance to write it down.
Yeah.
Okay, Daniel, what do you think?
Parentheses, K, X.
That's what I said.
But he's not just sitting there watching it. Okay, he's thinking. He has a brain too. Okay? Wait a minute, all you have to do is multiply?
Yes.
That is not hard enough.
Uh-oh.
I think it's...
We'll have to make it harder, but first let's see if you can do it when it's simple. Okay? So triangle RST has these vertices. Do you have to draw the picture?
No.
Can you draw the picture?
Yeah.
Okay, I want you to find the image under the dilation with a scale factor of 2 for RS and T. So find R prime, S prime, T prime, and I'll get victims to come up and write them on the board. Okay? So find those dilated points. I'm going to draw the pretty picture. R is at negative 1, 2, 3, 4, 5, 1. S is at negative 1, 2, 3, 1, 2, 3, 4. And T is at 2, negative 1. T. Come here, buddy. We can do this. Your job is to draw. Do the job. There you go. All right, I need 3 victims. 1, go pick a letter. 2, pick a letter. Kermit, pick a letter. Come on up. Yeah, go ahead, Bruno. You don't have to grab them, just write what their ordered pair is. Put the parentheses. There you go. Thank you.
Do I go get candy?
And you go get candy for standing up at the front in front of everybody and risking life and limb. Does that say 10-2?
Mine is 10.
Negative 10-2, thank you.
Oh, yeah, I'm doing the wrong one.
Oof.
Whatever.
You can write at the same time, Carmick, it's okay.
Oh, cool, okay.
So Alan says R went to negative 10-2. Let me get a different color. So R prime is over here. And then S prime, what does it say here for S prime? Negative 6, 8? So that'll be negative 1, 2, 3, 4, 5, 6, and up 8. Wait, that's 10. 1, 2, 3, 4, 5, 6, 7, 8. Well, sometimes these have 8 and sometimes they have 10. Okay, so there's S prime. And T prime is at, somebody wrote really small. Is that 4, negative 2?
Yes. Because I use the small one.
1, 2, 3, 4, negative 2.
It's still not your fault.
T prime. All right. So
Yeah.
a couple of things you should notice from the image. Okay? First of all, is it bigger?
Yes.
Okay. Was it supposed to be bigger? Okay, so you did something right. What else do you notice about the image compared to the pre-image? Well, yeah, sometimes your image will be, your pre-image will be inside, sometimes it'll be outside, sometimes they overlap. Weird stuff happens. This one happened to be inside.
All the sides are parallel.
All of the sides are parallel. Because remember, we have preserved shape, even though we have not preserved size. And since we have not rotated it in any way, everything should be going the same direction. So all your sides should be parallel. That's a good way to check your answer, is to graph it and see if everything looks the same. Okay? Questions, problems,
Complaints, concerns.
complaints, concerns, or comments?
Just that.
Uh-huh, okay. Yeah. By the way, what this scale factor is the scale factor for the side lengths, right? So what will be my scale factor for the area? Do you remember from our similarity unit? How do you find the scale factor for the area? Okay, first of all, how do you do it? Correct?
What? Yeah, can I? You have what you love outside, Austin.
Okay, go ahead, Bruce.
Two squared, right?
Well, how do you know?
I just.
Well, how do you know? What do you do?
Two squared around.
Well, the thing is that area has 2 dimensions, right?
Oh, right.
And so the length scale factor would be 2, the width scale factor would be 2, so your surface scale factor for your whole area became 4. This is where a lot of you struggled on your last unit. Lucky you, you're not going to have to do that on your homework. I was just connecting it with your homework from last time.
Oh, right.
Okay? That this still applies. This little bitty triangle and this big triangle, the big one is 4 times the little one. If you counted all these squares, someone starts counting squares just to verify. But yeah, there's 4 times as many squares in the pink guy as there are in the purple guy. Yee. You want to try another one? Or do you think you think one more? Actually, I have a better idea. Turn the page.
It gets better.
No, it definitely gets worse. Look at number 3. Is number 3 an enlargement or a reduction? But it's a fraction.
Still an enlargement.
Huh?
It's more than one,
How do you know it's more than 1?
because 2 halves is more than 3 halves.
Yeah, the numerator's bigger than denominator. The new is bigger than the old.
The numerator?
See? I wonder if it's connected. Everybody's just like,
The old denominator?
okay. So go ahead and find the image of this guy using the scale factor 3/2. See if you can do it with a fraction. You're like, dang it, now I'm back in 5th grade, suffering. You do not need a calculator. What do you have to do first? You have to find where all the points are.
Merry Christmas.
Hey, hey. Aw, thanks.
Happy New Year's.
Yeah, those fireballs are awesome.
Thank you.
0, -2. So T is at 0, -2. And S is at 2, -2. And Q is at -1, 1, 2, 3, 4. And R is at 1, 2. Did I find my points right? Did I do good? I don't know. I hope I did. Okay. Do we want victims to come up and get candy, or you want me to just ask you the answer sitting down, and you don't get candy for it? You'll come up and get candy, okay, so you come up, which letter are you gonna do?
Q.
Q prime? Okay, I need an R prime. Did you already come up?
Yes.
Okay, have you come up? Okay, so R prime, S prime? S prime, T prime? Oh, I need a victim for T prime, don't,
Do it, but I need a second.
okay. That's okay, they're gonna be in the way anyway. You don't need to graph it. But can you use the graph if you want?
Well, he's grabbing it anyway, so.
That's fine.
Yay.
Oh, are you able to graph fractions? Is that possible?
I mean, yeah.
Yeah? Is it fun? No. At least they're halves. At least they're halves. You can eyeball those pretty well. So when I give you something like 0.1415962 blah 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 that you start to panic.
Hey, I know that number from somewhere.
Wait, do we get candy from that?
Yeah. That's why I'm surprised more people aren't raising their hands. So let's see, I hear that Q prime is at -3 halves and 6. Did y'all check them? So Q prime,
I think I'm right.
so 3 halves of -1 would be -3 halves, and 1 1/2 of 4 would be 6. So yep, I believe that. So there's Q prime. R prime is at 1 1/2, and they've written it as a decimal, which is fine. And 3, so 1 1/2, 1, 2, 3. That's R prime. S prime is that 3 -3? I can't read.
Yes.
Oh, because 3 halves of 2 is 3. So 3 -3, there's S prime. And T prime is at 1, 2, 0, -3? And that's T prime. And so, oh, I'm going to connect on my pretty dots. Does it look bigger?
Yes.
Do the things look parallel?
Yes.
You're very afraid. What's the opposite of an enlargement?
And then shrinkment.
We wish it was an enshrinkment, but alas, it is not. It is a reduction. Oh, look! A large triangle! Guess what you're going to do to it?
Reduce.
You're going to reduce it using a scale factor of 3/4. Go for it.
I believe in me.
You see life of pi?
Yes.
Do you think that's possible?
Yes.
You can do that?
Yes.
Have you ever seen someone do that?
Not in person.
Or heard of it?
Yes. There are many savants who can do stuff like that. Sort of like people who memorize the dictionary or something like that. By the way, y'all are going to celebrate Pi Day, right?
Possibly.
Totally.
Because it's a week from tomorrow. And you want to celebrate, and you can go anywhere for your pie. HEB usually sets out like a display for Pi Day.
Do they actually?
Yes. Or you could go to like House of Pie or something like that and whatever. Or you could just swing by McDonald's and grab one of their little cheap garbagey ones. Usually Second and Charles up in Conroe does something for Pi Day. But yeah, you got the week off for it. You might as well go do something on the day of.
I'll just go to Domino's. Pizza Bus.
You get the week off.
What does pi, what day is pi?
What is pi? You can calculate pi if you wait a second.
Is it, no.
What is pi?
Is it 3.14?
Okay, so what?
It's finally gone from me and I cried. I can never escape.
And then on St. Patrick's Day, you go and, eat all the green food and
Yeah.
stuff like that. Okay. Does anyone want to come up, or do you just want me to tell you? Let's just do it in our head. So where was A? A is at negative 1, 2, 3, 4, 8. And so what is 3/4 of negative 4/8? Negative 3, 6. Oh, how convenient that they were both divisible by 4. When you multiply by 3/4, then you don't end up with a fraction as much. Sadly, did they all come out that beautimous? No, they did not, because you must suffer. So where did B prime land at? Well, B is at what? 1, 2, 3, 4, and 6. 6 doesn't divide by the 4 on bottom there evenly, so we end up with what? 3 and 4.5. And C is at 0, negative 4, so it'll be at 0, negative 3 for C prime. Okay, so negative 3, negative 1, 2, it's negative 3 up 6. 1, 2, 3, 4, 5, 6. This guy, and 1, 2, 3, 1, 2, 3, 4.5. Does it appear to have parallel lines? Don't make me ring the bell on camera in front of everybody to let them know that you're not paying attention. Do they appear to be roughly parallel? Does my image appear to be smaller than my pre-image? Do you feel like you want to practice with a whole bunch of little individual points? Notice on these ones though, I give you the image. You're going to have to work your way backwards. Okay? So have fun with that. Yeah. What if I don't tell you the scale factor?
What's me?
You have to be able to figure it out. Oh dear.
Old, new.
Whatever shall you do?
New over old.
Huh? Oh, I need to do new over old?
2 over 4. It's 1/2.
New what over old what?
Point number.
Yeah, pretty much anything. Could you do links? Sure. But I think points are a little bit simpler. So you pick a new point and an old point. Okay, so I need one of my old, well, let's do a new point. I need an image point. Someone tell me an image point you can find. The ones on the zeros are the simplest. 0, 6 is and that's an original, so that's what? D? So D is at 0, 6. Okay, so where's D prime? It's at 0, 2. How do you set up your scale factor? So I need to do new over old. So it's got to be the 2 over the 6, which is? Always simplify your fractions. So your scale factor is 1/3. Could we use the zeros?
Yeah, well, no.
No. For a couple of reasons.
Rule number 1.
What's rule number 1?
Don't divide by 0.
Stay in the middle of the trip. No, it cannot divide by 0. Okay? And so if you tried to do 0 over 0, you can't do it because that's undefined. Also, if you were allowed to divide by 0, what would 0 divided by itself be?
0.
What's anything divided by itself? Would it be 0 because it's nothing cut? Or is it 1 because it's divided by itself?
There's 1, 0.
This is why we're sure.
Well, what's anything divided by itself?
Well, there's an exception.
Okay, so that's why we don't get to divide by 0. Universe-ending paradoxes can and will occur. And so we don't divide by 0, so never use the zeros, use the non-zero numbers. Okay? Questions on how to find your scale factor? New over old. Turn the page.
Well, if 0 over 0 did equal 0, then your scale factor would be 0.
Is it possible for a negative scale factor?
Because the problem with 0
What?
Is it possible for a negative scale
because
factor?
like 1 divided by 0 is impossible. Because 0 plus 0 plus 0.
You might get a negative number for a scale factor, but we just use the absolute value of that. Because like if you got negative 1/3, that would just be like a direction, telling you which direction you're going in, just like we did with a -2 for a translation. And so that's all that would tell you would be its direction, okay? Because remember, vectors have direction and magnitude, so you need a both. Okay. Last thing. What's a sequence?
We already know this.
I don't know, you tell me. What's a sequence?
An order of things happen.
It's a bunch of stuff happening in order.
Yes.
So,
It's an ordered, well-defined series of instructions.
no, that's an algorithm. Get it right, that's an algorithm, all you computer people. Okay? So it's just the stuff in order. So, a famous sequence, Fibonacci sequence,
Yes.
starts with 1.
1,
And no, and then you do another 1.
2,
And then next is 2.
3,
And then 3.
5,
And then 5.
8,
And then 8.
13.
How do you know this? What's the rule for the Fibonacci sequence? Add the previous 2 numbers. That one's real famous for that. But a sequence is just anything done in order. The alphabet is a sequence. It's very exciting. And so we are going to do sequences of transformations. How many in a row do you want to do?
2, 5.
We could do like 10 in a row and like slide it and flip it and rotate it. And you don't, can you handle 2?
Yeah.
At least.
Okay. So a sequence is just 2 or more transformations done in order. And so, of course, you know, your favorite ones are what, the ones where you reflect over a line that's not an axis, like over the line y equals -3 or something. Those are always really fun. Okay? Oh, look, let's try one of those.
Let's triangle one of those.
So here, it says you have a triangle. It's got these 3 vertices. You need to transform it using a translation along this vector and reflect in this line. Okay, so let's do it. When I want to use this vector, what am I going to do to every single one of those points? Add 7 to the x value and subtract 5. Okay, so go ahead. Do that. Find G prime and H prime, or no, just G and H and I. Sorry, we haven't gotten to the end yet. So we're going to be moving along the vector 7, -5. So the G will become, ooh, what is G going to become? I had -1, I added 7, I get 6. I had 6, I subtract 5, I get 1. So you just use your vector just like we did on day 1. Do I have a victim to tell me what H became? Yes. -8, -2, and I became -1, 1. It was at -6, I added 7. And so it's just 1, 1. But see, that's why I don't love this unit. There's so many places where you can know the right thing and just accidentally do the wrong thing because your brain is overwhelmed with all the numbers. Are we done here?
No.
No. Now you take these inputs and you put them through the next transformation. So now I'm going to reflect them across the line y equals -3. Now how does it work when you're reflecting across the line y equals -3? Think about what kind of line is y equals -3? It's a horizontal line down here at -3. So if I reflect stuff over it, what happens to the x's? The x's stay the same. So keep x. Okay. But then how do we find our y? How do we find how far up and down these points are going to move to? Hey, y'all are quizzing this next class. Y'all got to be on it. How do we find where the y is going to be? Yeah? I can't hear you, what? This one? Let's see if it was. It was -1 plus 7. Oh, that should be at 6. You're right. Somebody used -7 by mistake. So that should be 6. Thank you for catching that. But still, I haven't. How am I going to figure out where the y's are going to go when I reflect here? Well, let's check. What if I had the point 0, -4? How would I figure out where its image went? How would I reflect this across this line? Yes?
Find the distance to the line and then like add that.
Find the distance to the line and then go that far the other way. So if my line is at -3 and I need to move up 1, that would be at 0, -2. You do that for all of your points. So G prime, what's going to happen with our x? What are we going to do with our x? Stay the same, keep x. Okay? And then for y, we're going to count your distance to your line of reflection. And so you go, okay, how far is 1 from my -3 line? So I was at 1, 2, 3, 4, 5, 6, 1. How far is that from the -3 line? How far is 1 from -3? It's 4. So my reflection, this number should be 4 in the other direction from -3. What's 4 below -3? And that's going to be -7. A lot of you are busy trying to do your homework right now and you're not paying attention to how to do this, and then you're going to cry more than you normally would. Okay? So where is H prime going to go then? Well, what's the y value for H going to be? Because we got 6, -7 there. What's the the x value going to be? H to H prime, what happens to H? What happens to x? It stays the same. Okay, so for I prime, what's going to happen to its x? It's also going to stay the same, so I can do that one as well. But now for my y values, you're going to have to count your distance. So for my H prime, I need to see how far is -2 from -3. It's 1 above it, right? -2 is 1 above it. So my reflection should be 1 below -3. What's 1 lower than -3? -4. Think in terms of above and below instead of adding or subtracting. Okay? And then where is 1 compared to my line at -3? And it's 4 in which direction, Carmen? Above it or below it? Okay? So if it's 4 above it, I need to go 4 below -3, which is at -7. These are going to be the hardest ones because they don't have a rule. You have to count them. You can draw the picture, do whatever you need to help yourself, but that's it, guys.